Let us look at this question, NEET 2018 question from electrochemistry. Consider the change in oxidation state of bromine corresponding to different EMF values as shown in the diagram below. BrO4 minus giving BrO3 minus, HBrO giving Br2 and then Br minus. Their potentials are also given for that is their reduction potentials. Then the species undergoing disproportionation is. Disproportionation means the same species undergoing oxidation and reduction. So that is what we need to find. So let us first write down the data given to us. That is BrO4 changing to BrO4 minus giving BrO3 minus. The EMF associated with it is, let us take it as E1 equal to, on the arrow it is given 1.82 volts. And the next one is BrO3 minus giving HBrO. The EMF required is 1.5 volts. So let that be E2 equals 1.5 volts. Next one, HBrO giving Br2. Giving Br2. 1.595 volts. E3 equals 1.595 volts. Now Br2 giving Br minus 1.0652 volts. E4 equals 1.0652 volts. Now let us find the oxidation state of bromine in each of these species. That is BrO4 minus. Let X be the oxidation state of bromine here, plus 4 oxygens are there. Minus 2 is the oxidation state of oxygen into 4 equal to minus 1 is the overall charge. So X minus 8 equals minus 1. X equals minus 1 and this minus 8 will become plus 8 here. So it is plus 7. So bromine is having plus 7 oxidation state in BrO4 minus. Next is BrO3 minus. Let X be the oxidation state of bromine. 3 oxygens are there. Minus 2 for 1 into 3 equal to minus 1 overall charge. So X minus 6 equals minus 1. X equals minus 1. This minus 6 will become plus 6 on the opposite side. So plus 5 is the oxidation state of bromine there. That is plus 5. So here also BrO3 minus, it is plus 5. In HBrO, let us see, HBrO, plus 1 is the oxidation state of hydrogen, plus let X be the oxidation state of bromine, plus minus 2 is the oxidation state of oxygen, equal to 0. No overall charge. So X equals, let us take those numbers to the opposite side. As minus 2 will become plus 2 and plus 1 will become minus 1. So it will be plus 1. So plus 1 is the oxidation state of bromine in HBRO. Here also HBRO, bromine is +1. And in Br2, it's the elemental form, 0 oxidation state. Br minus, that is -1, is the oxidation state of bromine. So these are the oxidation states of bromine. Definitely they are changing. So let us see which one is undergoing oxidation as well as reduction. Now we are given the EMFs associated with the change. So from this, let us identify cells. That is, say we can take this as a cell. So we can say BrO3 minus BrO3 is changing to HBRO. The potential is given as 1.5 volt. And we can write BrO3 minus changing to BrO4 minus. That is actually oxidation taking place. But here we have been given the reduction potential. This is the reduction potential which is given. So we can write it as 1.82 volts. Both these are reduction potentials. If we take like that, we can say E0 cell equals E0 cathode minus E0 anode. That is, this is oxidation, but the reduction potential is given. So this is the anode and this is the cathode. That is, here E2 is the cathode and E1 is the anode. So we can write here E2 minus E1. If we write it, E2 is 1.5 minus E1 is 1.82. 1.82. We will get the value as minus 0.32 volts. So similarly, we can find it for each of these cells. Say these two will constitute a cell and these two will constitute a cell. So if we calculate and write the E0 values of each of those cells, let us take this as the first cell. And for the second cell, E0 cell equals E3 minus E2. So E3 minus E2. The values are E3 is 1.595. 1.595 volts minus 1.5 volts. The value we will get as, this is a positive value, 0.095 volts. And for the third cell, E0 cell equals, we can write E4 minus E3. So E4 minus E3, that is equal to, E4 is 1.0652 minus 1.595. This we will get as a negative value, minus 0.5298 volts. So from these values, we can see that two are negative values. So if they are negative values, the reactions are not feasible. So this is not feasible. That is, it will not happen spontaneously. So is this one. So it will not take place spontaneously. Whereas this one is a positive value. This will take place on its own. So we can see that this is for the second cell, that is between BrO3 minus HBrO and HBrO Br2. So here we can see the common species is HBrO. So we can say HBrO is the one which is undergoing disproportionation. That is, option C will be the correct choice, HBrO. The others, of course, BrO4 minus, bromine is in its maximum oxidation state. It cannot be oxidized any further. So disproportionation will not take place there. Now in the case of Br minus also, it is in its least oxidation state. It cannot be reduced any further. So those can be ruled out. And the others, we have seen that they don't come. Okay, we have ruled them out because they are not undergoing disproportionation. So only HBrO is the one which is undergoing disproportionation reaction.